Hi,
Hi, Meho.
Srinivas, how are you?
I'm doing okay. How about
You're
you?
okay. Tomorrow you're going to give the lecture on latent models or latent.
Yeah, yeah. In fact, it's packed. The entire 2 hours probably will take longer. Even, I mean, there's a lot of math to get through and stuff. And I, it took me like I would say probably 4 or 5 times and watching a whole bunch of other videos to really kind of get a grasp of what's going on with all the various math
Okay,
thing, but at least it's very useful because I think it finally I'm beginning to glean some insights into what's mathematically. I mean, you can mechanistically it's easy to do, but to gain a appreciation for what is really happening and stuff, then I think it's very that at least I am happy I chose to do that lecture. It's very math intensive, so in some ways it's kind of boring, but in some ways it's really the insight into the math behind the just the pushing.
okay.
Because you can code without having a sense of what's going on, and this at least tells you what's going on.
So you are covering. Oh, it's you've
I
covered.
started. By the way, if you
Yeah.
are sorry to interrupt, but if you're interested, I think you should probably listen to about I would say probably the last half an hour or 45 minutes. I forget now of last week's lecture. It is on the um, I've
Okay. Uh-huh.
posted the recording, and that will give you a good because that part I'm just going to whip through um, very quickly because we did spend some time last week on it.
Okay.
But it kind of sets the context of what we are trying to do. So
Okay.
I think
Okay.
it'll be good if you have the time to just kind of, a lot of it is the first part of it is still completing the flow. You can skip through it. You can skip that part and just end up in the last half an hour or 45 minutes, which is the part where I am talking about latent models.
Okay. Cool. Okay. Cool. I'll review it and then join tomorrow. Yeah.
Yeah, because that's, it's kind of pretty good
Yeah.
coverage of the subject
Okay. Cool. No, I'll definitely join. Okay.
from a totally probabilistic perspective.
Mm.
So I think Steve won't be joining, so it may just be, let's
Yeah.
see, there are a few others.
Yeah. Gautam and Sivarama. Yeah.
Hey,
Yeah, so um,
Yeah, I have some updates. I've been trying some submissions and trying a few things. Yeah. Uh,
yeah, go ahead. Why don't you um, go ahead and I just had a couple of simple questions. I
okay.
actually hope to be much further along, but I haven't even made my first submission yet. But I can ask my questions
Okay.
as we go
Okay.
along.
I'll share my book. I'll share my screen and um, yeah. So definitely this competition. There's the data set is challenging, right? So um, there are. Let me just show you two public notebooks and then I'll show you what I was doing. Code. It's not by most code. Okay, so two ways to think about data. Okay, so one way is what he's done is that like we have talked. It might be the front view, top view, or side view of the data. It's a 3D data set, so it's like axial, coronal, sagittal, and it's not consistent. And there are for each patient there are four data types. Just to summarize, so flare, T1 weighted, T1 weighted contrast and T2 weighted. Okay. So what this person did is, okay, so you see, this is um, just this is what, so he called it study ID, but this is subject ID, right? And this is one subject and the four images, and the four sequences: flare, T1 weighted, T1 weighted, CE, and T2 weighted. And he's just displaying the three orientations. He did some the
Sorry,
dicom. Yeah.
Mehul, on one. So my understanding from our last week, and I wanted to kind of reconfirm because I confused myself again. So the top column names are where he starts off, correct? Meaning for this patient, meaning study ID is just an indicator for a patient. So I'm just going to stick with patient because that's descriptive. For this patient, this particular image is flare image, coronal, and then what does the three rows represent?
It's
The it's the axial, sagittal,
Karun.
And coronal for sorry. So because that's where I got confused. So the
Yeah,
flare coronal is of
yeah,
the flare type, scan type, and then this is coronal image.
right. So, yeah, exactly. So, these are the original labels, what the data is in. And yeah, I think maybe I should change this notebook just to make. So, the original labels are here. So, flare was coronal, T1 weighted is axial, T2 weighted is sagittal. And then here, the displays after the resizing and the reorienting, so that all of
And
otherwise,
the
yeah.
correct, but all of these images now are what orientation are they in? Is what I
Oh,
got. Are they
okay.
in the same as coronal?
That's yeah. So
See, it
I
doesn't explicitly call that out even in the display, and that's what I was confused by. Is he,
yeah.
you know what
I,
I'm asking?
right. I think I do. So the I think after reorientation they are axial. But how can I confirm that? Because once you reorient it, right, you have a you have a 3D uh, 3D data set. You have a 3D array, and if you want to do displays like this, you just say, so you say voxel, and you just show the first dimension. And if you so this, it's like a 3D array, and you just show the 2D plane. And if then you say you want to show the middle plane, then you can wait. So in this case you show, um, yeah, so
Pivot plane.
yeah, you basically can look at the different planes like this, with these three ways. um, okay, so maybe he did. I should try and figure out what is the orientation after all of this, like but they are always in the same orientation. So that's the great part, right? Every subject is, you have the 3D array, and every 3D array is now, so when you look at the data in a particular slice, you will see axial. If you Yeah. um,
Yeah, I got that. And actually, he does one more thing, which I thought because I coded
yeah,
it on my own, followed his code
yeah,
exactly. And what I understood also, another useful thing he does, which he points out, which I don't know whether anybody else has figured that out because I didn't see that in the comments, is he says that, and he fixes this problem. He also points out that even if you take, let's say, and I'll take axial for simplicity, although I think he points out that this is more an issue in sagittal than in axial. Okay, let's stick with the sagittal example. So what he says is, see, sagittal means you go from from one ear to the next,
right,
right? That's the way you go in Sagittal, image from one ear to the next. So what he says is that the other thing which happens is apparently sometimes the image is from the left to the right ear and sometimes it's from the right to the left ear.
Okay.
And that is another thing. And if he notices that, if you see, he flips the image around.
Okay.
Flips meaning where he does this first thing, voxel -1. He's actually flipping the entire 3D image along the last axis in order to get that, in order to reorder the plane.
Okay, I see.
I thought that was very insightful as well.
Yeah, I missed that. Yeah, I definitely missed that. Okay. Yeah. So then,
while we are on this, I had two questions since my questions are primarily related to this.
Yeah.
So, as I understand it, and obviously correct me if I'm wrong, but we can then use. So he creates a voxel, which is like a 3D kind of image from a single, from all the slices of image per patient per scan type. So for example, a FLAIR scan type will have one 3D image for that patient. And he does this actually also clever thing where he orients or he chooses the pixels to normalize and stuff, or not normalize, to slice based on the deepest dimension, because that's the one that will give you the best result, right? So he figures out which of X, Y, or Z is the largest, and he then creates the dimension based on that. Okay, so now setting aside the segmentation thing for a minute, if you then are able to classify using a 3D network, right? And let's set aside this segmenting for the tumor aside for a minute, then you should be able to just apply a 3D trained efficient net or whatever equivalent to these images and do a prediction. Correct?
Right. Yeah.
Right. And that's meaning, what results it may give and all that is obviously things to be looked at. But now the other question I had is, so in order though to apply this to the test images, you would then need to pre-process, take the test images also through the same pre-processing before you predict. Is that correct?
That's correct. Yeah. Yes, exactly. And because this is a notebooks only competition, so your notebooks needs to have that pre-processing for the test images. So that's exactly what I did.
Okay.
That's great. I just so what he did is, he did this part, and then he created 3 data sets and shared them as Kaggle data sets. So I think that's a great segue for the so basically I took the notebook Steve was using, that single efficient net, right? And so the changes I made exactly follow what you said. So I changed. I have to keep the pre-processing step, because otherwise the test images will not work, right?
Correct.
So what I basically did is, if it is training, and I added the NumPy files to my notebook, so you can add data set. And I said, okay,
exactly.
Yeah, and I basically that's it. So all I'm saying is, if it is train, then you go and fetch the take the NumPy from the already created data set by just this fstring thing. And otherwise, if it is testing, then we have to do the 3 steps, like get voxel, normalize, crop, and resize. That's it. And then someone Actually, this follows exactly. So I basically changed the load DICOM images method in that script in the and in this one it is a PyTorch. I think somebody has a pre-trained efficient net. I'm not hundred
Yeah,
percent.
yeah. There was an EfficientNet 3D that I used as well, and I could.
Yeah,
In fact, there's
and
a public notebook which points to it. In fact, this guy might be using it. The EfficientNet 3D one, public notebook guy might be using one too.
one use. Yeah.
Yeah,
Where is my thing? Okay. Yeah. Yeah. I think it's the this one efficient net PyTorch 3D.
that's
Uh,
right.
and there's some funny stuff happening in the training, and I wanted to discuss with you all. Yeah. Okay. I mean, okay. Maybe the results. So okay. So now when you train at sorry for scrolling so much. You train one
No,
type at a
uh,
time. Sorry. Go ahead.
yeah, yeah.
Um, and you see
So
it's
you're using
uh,
all the flare images and doing the training, right?
yeah, I need to
Do you
so
do train test split?
yeah, I split 80-20 split. um
Okay.
uh, yeah, yeah, the some of the terminology is not great, so like my validation AUC is, and I think this is also following what you were saying last week. You see, like my validation, it still sucks, like it's still 0.632 is the best, right? But then when I submit this on on the public leaderboard, it's all my score is always zero point 0.5, which is something weird because even there is another notebook which proves that they did some simulation and they said that if you are doing random guessing, you should get like
Right.
0.65. And
Right, but that is where though. So two or three comments right on that subject, right? Because we touched on it last week as well. The first is a very simplistic comment, but at the same time, let me make it just so I repeat it if only for my own memory. One thing which might be good, and I started to do all this, is getting rid from your I don't know that you need to get rid of it from the data set, but getting rid of it from at least your table that you use to process the patients. Is there are three patients with problematic data,
yeah,
and even the
uh-huh,
competition guys have said eliminate it. I mean, and it's like patient ID 109, 123, and 709.
right,
So
yeah,
you should, if you have not, then you shouldn't have 585. You should have 582
right, yeah, right.
when
Yeah,
you
I dropped
split.
those three cases. Yeah, because yeah,
Okay,
my
okay. So that's good.
mhm, mhm. Yeah. Go ahead. Yeah. Mhm.
That's one. The second is um, that uh, the second is I think the most important comment, and then which is, see, because the number of private test cases, what, 87 or 70 something or
80.
80
Yeah,
something,
87. Yeah,
87, right?
yeah,
I think that is where uh, at least a lot of commentary I have seen, and I tend to agree with it, is that I don't know that you should go by, that we should go when if we select what model to submit and or um, evaluate, that we should be evaluating it on the test set, because rather than on our own validation set.
validation. Okay.
And
Hmm.
while I'm on that subject, the one other comment I would make is the other thing you could potentially do, both to check whether your um, validation score improves and or changes, because if it doesn't change, then there is something else that's wrong that's going on, is to do a stratified split of, rather than an 80-20 split of your, based on the NGMT preg of your data,
Okay.
because that is something I did as I was splitting.
Okay.
like, because
Yeah.
the 80-20 split may or may not give you the right, because it's slightly imbalanced, if I recall, the data set.
Mm.
It's not too much, but it's slightly imbalanced.
Okay. Yeah, I was just trying to see how I did how the train test split. Oh, I did stratify. Yeah, okay. Sorry, sorry.
Yeah, you have stratified it. Okay, okay.
And
So
still,
then that's fine. Then that comment is not valid because you already have
and yeah,
stratified and eliminated.
yeah, and this is where I dropped those three cases because yeah, it was failing
Right,
otherwise.
right,
Yeah. Okay.
right. Yeah, yeah. That makes sense.
It's I feel like I'm going a little blind because I can't figure out if the model is actually learning, and
Mm.
uh,
Oh, the
it's
other thing,
yeah.
obviously, the last comment I would have is, that's where this whole segmentation thing
Hmm.
comes in, right? Because the other, and this is where having an idea like you do of how that voxel is and stuff can help. Because one other thing which might be interesting to do, obviously the perfect goal would be from each of your voxels, right? Um, take only the segments that have the tumor, right? That's
Hmm.
kind of like the perfect goal, because right now you're using a lot of data which doesn't have the tumor in it, right? Like all the portions of the voxels which don't have the tumor present. But the other simpler thing which I've seen many people do and get at least 2.6. So what is your score with this? You said
No,
on the
it's
test it's just 0.5.
yeah, it's always point 0.5. So I've done like
Okay,
last five iterations are all point 0.5.
okay, that's really strange. But the other thing I've seen people do, and it's crazy. That's not a approach I would recommend for, obviously as we go to the competition, but to just see whether it changes is take some set of voxels from the middle, dropping the top and the bottom,
Mm-hmm. Yeah.
and submitting that, right,
Okay. Okay.
using the 3D model, and seeing whether that actually helps you change the score.
Okay. Okay. I see. Yeah, I should try that. Right now, so far I tried.
Like,
Okay, dropping.
you
I'll
could use some, 100 slices or 200 slices, or, like, of course, you have to be careful because your number should be bigger than the smallest one, right? I mean, or smaller than the, uh, uh, your chunk should be smaller than the smallest chunks that exist in your data.
okay. Yeah. Okay. I'll try that. I've
Because the very surprising thing is, I've seen some people get to 0.60 something with just submitting 20 slices.
wow. Okay. Yeah.
And amazingly, 20 slices of some, like arbitrary combination of all four. So take 20 slices from all four scan types, shove them together, classify on it, and get a score. I mean, it makes no sense how they got
Yeah.
there,
Yeah.
but
I
but it.
yeah. I need to check if I. So this is another funny thing. Like I have, because originally they were doing. I'll show you the diff, right? So this is the original notebook,
Hmm.
and then this is my latest one. A lot of bugs in between. That's why it went up so fast. It was crashing for weird
Yeah.
reasons. Yeah. Uh, but I only changed. It's like I changed things like like instead of I'm loading the numpy images, right? And yeah, he had this dicom function to load things. uh, Maybe this video, I don't know what this in the original notebook there was some VOI.
Yeah, no, yeah, but that is just, in fact, I have a note here. The VIO last thing, let me tell you, it is just because I kept encountering it until I was like, okay, I'm not going to, let me write this down. So give me a minute. So what that says is it says VOI LUT, because it's basically a lookup table, determines what range of pixel intensity should be shown on the screen.
Oh, I see. I
And
see.
it uses typically linear, sometimes non-linear is also possible, such as sigmoid. So an array of values that maps the source image intensities to the output range.
Okay, I see.
And if it is not found, meaning if VOI LUT is not found, then image is scanned for min-max pixel intensities and the lookup table is built to display, where the minimum intensity is black and the maximum is white. So that's what the VOI LUT is for. So I
Okay.
don't think, because he applies the contrast in our case, right? Because he does apply contrast to every image.
Right, right.
That's
So we
where
don't.
the right. So I don't know that that could be a potential reason.
Okay. And then yeah, the other thing I think I kept, yeah, the training loop is all the same. Um,
Right, right.
I
Oh,
didn't
one
change.
more question. Did you change sizes and did that have any impact? Meaning, did you try it with 64, 128, 256?
Yeah, it's I should 256. I was running out of space, which was weird. Like I get like a lot of those errors were like there's not enough RAM
Out
on
of
the
memory?
GPU. Yeah,
Oh,
but the other people it works. So I'm not sure what I'm doing wrong. Batch size maybe I tried. Yeah, all of this is like I think that's one of the problems with the notebook competitions. Like you don't know you have when you run it and then you're like, oh, okay, it fails. So it's this one failed after. I think we can probably see output, but I think it's nice to see. You can see, yeah, see CUDA out of memory, and
hmm.
I'm getting blah 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 errors like that. But this ran for almost 10 minutes, and then after 10 minutes, I got this error. So I was like, crap.
And that's
Um,
for size 256.
Let me see. I think so. This is another nice thing about the notebooks. Like, yeah, everything. Oh, this was even for weird size
64,
128, and
120.
yeah, and the batch size is 64. I was yeah,
You
yeah,
can
yeah,
reduce the batch size though and get around that, right?
get it, yeah, yeah. I think eventually I went to 32 batch size. What else
Mm.
was interesting here? Let me see if there's anything interesting in the training. Maybe is very simple. Maybe you can do something better in the sense you see, like here, this model is very simple. Like it's that efficient net 3D, and you can pick a B0 or I've just been playing with this one right now. And
Mm.
then after that there is just one one fully connected layer. So normally
Yeah, yeah.
we could have two or three, like we make this little better with some
Yeah,
um
you can have dropout and get
yeah.
but I don't know whether, you can stick a couple and stick a non-linearity in between but,
Yeah,
um, I, one, again, among the things that I had in mind to try and, after getting the basic thing working, basic pipeline
yeah,
is, um, are a couple of things I thought of, which is why I asked you the size question. Is you know um,
yeah.
in Fast AI, Jeremy talks about this progressive resizing. So I was
Right.
curious
Hmm.
whether, but obviously that works better if the network isn't. I'm trying to think whether that is the case. You do without a pre-trained. Uh, no, you can use a pre-trained. You can use, I think, but basically first train it on a 64 sized image and then maybe fine tune it on a 128
I see. Okay.
sized image. You know what I'm saying? So you first
Yeah.
train a model on 64 sized images, get that model, and you use that model and fine tune the model on 128 by 128 images.
Okay. I see.
That's one idea I was thinking of once I get the pipeline working. The second thing, I think this guy or one of the notebooks already, and maybe this guy in the public notebook itself, right, is I think either this guy or somewhere else I saw is using label smoothing as well.
Okay.
Right, which is to reduce kind of the confidence and between the 0 and the 1, kind of spread that around a little bit more, make the 1 a 0.9 and then spread all the zeros, increase it to like whatever fractions.
Okay, I see.
I thought either this, if I find that notebook, I might post a link to it too, which implements label smoothing.
Okay, label smoothing. Okay. Yeah, the other, okay, so I can check this. Okay, batch size, try some more layers here. This is standard PyTorch stuff. Nothing, I think maybe having some better learning rate scheduler will help. I think he didn't use any. Yeah, you have.
Oh, of course, you know, another thought while we are on this particular subject is using some kind of augmentation by maybe flipping and or rotating the image.
Yeah. Yeah, I think the original notebook had it. Then I had to remove it because of the way I'm. But I should. Yeah.
Yeah.
But once I have NumPy files, so I should be able to do augmentation. I just need to find how to where to stick it in. Um, oh, do you remember? I saw some people. Yeah, these were two questions. Like I saw one was Adam. I think Adam is the one people are preferring, right, over SGD now. Like Adam is like become
Yeah,
a
most of it people just use Adam with
Adam
one init 3 to start off.
1 init 3 to start off. Okay, that's why he did that. Yeah, and then for the loss function, binary cross entropy with logits. Right?
In this case, I've seen another notebook just use cross entropy too, because we just have two classes. So
right. Yeah.
it's not critical to use binary cross entropy. I mean, of course you can, but typically that is used for this multi-label situation, right? I mean,
Oh, I see. Okay.
binary cross entropy with logit, whereas just using cross entropy works good enough if you have two classes. But you know, this is the more general case. So
Okay. Okay, I'll do that, and then yeah, some other things. I think I need to put in the work and just log everything with weights and biases. Um,
yeah,
because
I
I'm
haven't started to do that.
yeah, right now I'm just manually. So I think I tried like 10 epochs, 25 epochs, and I think this is the patience factor, like how much it will wait. Let me see. The last thing I tried. Okay. Yeah, and the scores take some while to come. So I submitted this 2 hours ago. Which
Wow.
is yeah, it's you just, I don't know. Maybe it will show up eventually. Why? I don't know what does it did it time out? Oh, yeah. Wow, really? Okay, that's weird. I never.
I haven't seen that before. So
Yeah,
you ran out of your cycles?
notebook exceeded allowed compute. Wait, there was some. No, so normally I was getting this error, notebook through exception, because some of the DICOM tags were missing. That's what I was getting initially. Where? This indicates you have violated a code requirement constraint. Okay, I don't understand why. Okay,
Oh, it
okay,
says more memory, RAM or disk.
okay.
By the way, another question: do you attach all three data types? Because you might want to, if you're only using 64 or something, get rid of the others.
Oh, that's a good point. Yeah, I attach everything. Yeah. Uh, okay. Yeah, yeah, I attached the inputs. My input attaches 175 GB now. I mean, of course, some of it is just the
Yeah,
original data, but yeah,
yeah, but you may not, if you're working with 64, then you may not want to put
yeah.
128. And I mean, each of those I don't think is that big, but I guess if it's giving you problems, then
Okay, yeah, it might be. Okay, this doesn't work. Yeah. Also, this is when. Yeah. Okay. I was. Okay. So the other thing I tried. So there's this initiative called. I haven't made a submission with this, but um, uh, so there is because like now so there is an initiative between all these universities and companies. So it's like an industry academia partnerships. So it's like Stanford, Nvidia, King's College. So they've been building this open source medical imaging package, and you we can. But the input to this is Nifty. So what I ended up doing was
oh, input is Nifty.
yeah, because that's like become a um, very popular like medical imaging format. So I took those NumPy files. One of the other notebooks had a use ITK to convert the NumPy to Nifty, um, ah, and so the convert script is very small. It's only oh sorry I think I just used like there's another Python package like so I just converted them
iBabel.
to yeah Nibabel. I just converted them to Nifty. uh, I had to I yeah, and then I can once I
So
do
this,
that.
by the way, this notebook, or do you have another pointed to another notebook which is public that does that, or can you make this particular notebook very used to convert public?
Yeah, I'll make it. Yeah, it's on a local machine, so I'll copy it over and make it public. Uh, and then uh, when I'm so then in the Monai, so lot of they also have like a 3D example, um, but they have also the nice thing about them. I'll show you. I thought what they did is quite nice. Is um, yeah, it's PyTorch based. So you get your once you have your nifties, I could start testing very quickly. Like what was my maybe this is it is slightly better than the other Kaggle notebook I was showing you. I think sorry. Okay, 0.57. So
But I
the
thought
main
you got to, is it, but these seem accuracy scores, not AUC scores, correct?
yeah, I need to fix. Yeah, sorry, I need to fix that and. Yeah, yeah, you're right. These are accuracy scores. So one advantage of this Monai thing was one it has a lot of did I kill it? Come on. Okay. Yeah, so that's the efficient net. that's been implemented, um, and yeah, okay, I need to see. I think I did see pre-trained somewhere. So they have EfficientNet, DenseNet, a lot of those. Let me.
Hmm. And they have it pre-trained on medical images.
Yeah, I was just trying to find exactly. I was just trying to find that answer. See, it says densely. Blah, blah. I thought I saw it somewhere, but I couldn't. Where did we go? Blah, blah, blah. I'll try and find. Yeah, I just haven't made a submission with this one, but yeah, um, okay. So the one, yeah, okay. So I'll check whether they are trained. Check if on medical trained. The one thing I really liked is I could, like you can um, you can build your own DenseNet. So you remember in the paper, you have four like DenseNet 121 is okay. Why is it 121 layers? Let's see. Dense DenseNet 121 architecture. Uh, okay, so that's from the paper. So So DenseNet has 5 layers. Let's see if we can figure it out. One, two, five layers, and then they have expansion of four. So does anyone remember this architecture? This has become very popular too in some of the. So there is they
Yeah,
have
in
this.
fact, when I did the bird thing, DenseNet 161 or 121 was the one that was giving the best result.
I see. Okay, here we go. Maybe here. So blah, blah, does it? Oh shoot! I was hoping it would have. So yeah, these are the dense blocks. One, two, three, four dense blocks, and ah, okay. So six plus 12, 18, 18 plus 12. Oh, there's one by one. Okay, I'm not getting 24. This is 40, 40 and 18, 58. How do we get to 121? Um, Okay, I'll try and find that. But basically, you can so these are the four that were in the paper: DenseNet 121, 169, 201, 264. So one idea I wanted to test is this ImageNet is really complex, right? It's a really with so many categories and so many like nuances. Even in the dog category, it's um, like I can barely tell some of the categories apart in image. So but this the challenge we have is not so complicated. So I want like to create my own dense net with 20 layers or 25 layers. And I think so with this Monai, they have a base dense class, and then you can there are some features like wait, let me just open the help. I think that'll be. Yeah, so how can I make this bigger? No. Can we read this? So this is following the paper, and then um, yeah, basically growth rate is how many filters to add in each layer. Uh, yeah, I think this, because this forces me to go and read the paper more, and uh, like, okay, try and understand, okay, how I can build my own dense net with smaller layers. Like my so the experiment I want to try is that, okay, if I do 25 layers versus 121 layers, okay, how much difference is it in performance? Do I really need these many layers for this medical imaging problem? So this gives me, like very easily I can try these experiments, right? Um, and the other nice thing about Monai is the list of transforms that they already have. Is they divided it into categories, and so like some is like cropping, right? So either center crop or random spatial crop. Um, so now I have 3D, so I don't know if I should crop in uh, like X and Y, and or do a 3D crop. But I just have to try that experiment and just try it out and see. Um, the other thing I didn't know is like, so that was all the cropping transformations. These are all the intensity augmentations. So some of it I was familiar with, like I'm familiar with like Gaussian noise or normalize or um, some, but Gaussian sharpen, Gaussian smooth was new to me. Um, Gibbs, there is something about the MRI physics, like how the data is acquired, and based on that, there is the noise can have a distinct different distribution. So I think the Gibbs comes from there. Um, yeah, give the intensity, and then what else? Yeah, and so intensities, random cropping, and then the spatial transformation. So like you're saying earlier, Srinivas, like flip it, like left, like horizontal, vertical flip, any flip, rotate it. So orientations, um, and there is um, so in image registration, right? Before there is so you can have rotation translation. You can have affine. So affine is like shearing, like shearing the image, or you can have something called non-linear transformation. So all this elastic stuff is non-linear transformation. So the nice thing is it's all built in. I Yeah, and see, I got. Uh, I think the so far what I observed was I had a Google Doc, but it was reaching like the best performance very quickly, like in Epoch, Epoch 2, 4, 6, 8, and even though I ran 30 epochs, but yeah, that's so these two, yeah,
And what's
that's
the head on these guys? It's just you just take, and it's again very simple, right? From what I see, it's just a linear thing which converts it to two outputs.
yeah, that's it. Yep. Uh-huh. I should yeah, and they gave me the option for pre-trained, and I was just playing with it. But I think maybe I should make some submissions and just see how, and also change. This was their default, so then I need to maybe do like maybe get the AUC and work with that. Uh, I could get if so with this code I haven't made any submissions. I only made submissions with the notebook I showed you. So, but I could get efficient net and dense net very quickly. And then, like you're saying, right, I just want to get a working pipeline. and then we can experiment as much. There is enough compute on Kaggle now, like for 40
Right,
hours.
right. The only major thing in any of this, that I feel, and that's where that's a significant challenge that I haven't yet. I just want to get this simple thing working, which I haven't yet made any submissions on it. I'm kind of,
Yeah.
if the next big step would be bringing in what Steve was going for right away from the beginning, but I'm much more modest to get something working, is applying the segmentation part,
Yeah. Yeah,
right?
because
Because
right.
basically applying the segmentation will then make the images or the portion of the images that is relevant, that is only the tumor rather than any part of the image that's uh, uh,
Right. Yeah.
not
Yeah.
or using slices of images which don't have uh, the tumor in them.
Right. Yeah. Um, yeah, that will definitely. So that will. So then we mask it, right? You apply the mask before feeding the voxel in. So you force it. It's kind of, or oh, how about it's kind of like an attention, right? So you want to say, okay, focus your attention inside this mask. But how can you use some like an like in the traditional attention layer, you don't tell it that, okay, focus your attention only here. You see what I mean?
Yeah, no, in this case, it would be basically um, learning. In fact, it's two-step process, as Steve was articulating earlier, right? Which is um, learn to predict where the tumor is, because that's what the other kind of sister competition to this one
Right. Yeah.
is, right? So you have to be able to predict, given a set of images, predict where the outline of where the tumor is. So you have to kind of learn that and have a model which is able to do that, and then use that model on these images to predict where the tumor is, and um, using that prediction, which will be a mask, and using that mask to then pick out the relevant portion of the image to use in the classification.
Okay. Mhm. I see. Okay.
Right. So right now, I mean, as I was saying, you could potentially, let's say in Flare or any of the scan types, we could choose, and here we are choosing arbitrarily some X slices of the image, um,
Right.
which
Yeah.
supposedly had the tumor, right?
Right.
Whereas the goal would be to not pick X kind of on our random choice in the middle, blah, 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 but pick X, Y, and Z, where first use a network to predict the X, Y, and Z where a tumor is, and then use those X, Y, and Z to limit the voxel to only that size.
Okay. Okay. I see. Uh, yeah, and every image has a tumor, so we know. Yeah, you can segment
Right.
it. Yeah.
So it's just a matter of predicting the X's and the Y's and the Z's so that we know which subset of voxels to use
Right.
to provide to our classifier.
Okay. I see. Okay.
And that would
Uh,
be, obviously a range of X, range of Y, range of Z prediction mask.
mhm.
That's what I think Steve was after. So maybe in
Okay.
a couple of weeks he can update us
We can try
where
Unicum.
he
Okay.
is on that.
Okay. Uh,
Yeah, if you can post that thing where you convert it to Nifty
sure.
stuff,
Yeah.
and then this one is just plain using those Nifty images then to use is Mon AI just a matter of how do you use the Mon AI? Do you have that in this notebook or?
Yeah. I just did. I think I just did pip install and then just import Monai. That's it.
Oh, okay.
Yeah. And I can. Yeah. I can. I've seen. I've seen other people use it in Kaggle. I think that's where I saw it first. Code. Yeah, this one.
Oh,
This one is in RxNA. They also did some. Yeah, that's all he did. He can just get it like this. Pip install, and he did. But he had. I think that's the only thing. Like he had managed to make JPEGs. So I don't know resize. So they went. Okay, maybe that's not a bad idea. So they because they so right now we are like Monai counts Flare as one channel, so it has the flexibility to work with all channels together. Um, so I think what they did is they made a 160 by 160 by like a four-dimensional data set with all the channels. But I just need to look at how they did it and RSNA blah blah blah. Yeah,
is
see,
it
this
for
is
this competition or something else?
no, sorry. This is for another medical competition last year.
Okay.
Yeah.
Yeah, because
Yeah.
for us, it's not a good idea to combine the four channels as
Yeah.
channels
Right.
necessarily, does it? I mean, if we can do it, but why would you, or what would be the purpose of it?
Yeah. If we do the registration, maybe like there is some pattern that it when you have a MGTM, maybe T1 weighted and Flare have a particular pattern. Maybe so we do it like in sometimes we do this in classification of Alzheimer's patients. We look at like two images together and say, okay, it changed like this on T1 and it changed in this way in T2, and so maybe that helps. But yeah, but there's nothing like sure that like eh, just an idea. But yeah, but then it has to be registered, so it has to be the same brain region in T1 and T2. So you have the extra registration step, uh, and I don't know if he might have done it. I'm not sure if he in when he created those numpys if there's registration or not. Uh, yeah, one yes. I think this is challenging way but it's good. It's good in a way because a lot of the real life data sets are becoming like 3D and 4D, right? Like two like so it's good to. Um, I think it's good to good practice to work with like a 3D data set. And in this case, it's like four with the different channel, it becomes even 4D. Um,
Yeah, the one other comment I heard, let me ask you this since you have dealt with
yeah.
these kind of images before. Somewhere in the comment, and I don't know whether it was anybody with experience in the medical field making this comment. So I'd like your kind of opinion on it. One of the things that I read in either the discussion or something said, oh, you really don't want to do the analysis as 3D.
Mm, yeah.
Instead, you want to do the analysis as a sequence of images, but
Mm-hmm.
obviously that is quite like using a LSTM or at that point,
Yeah.
an LSTM like seek-to-seek type of model. And the reason he was giving that person was giving or articulating is the following: that um, the obviously as we process the image, every image is going to have a different thickness, right? Because we have seen that even if you
Yeah.
choose the longest dimension, obviously we saw, as I showed, I think last week or week before, that there are like a dozen different sizes
Right.
in
Right. Yeah.
in
Hmm.
any of the dimensions. I mean, there are like 17 or 19 or 25 or whatever in the width. I mean, the height is smaller, but it's still 12, and the thickness is again varies from even within a scan type, it varies. So
Right.
the point the guy was making is that image to image, your thickness in a 3D thing, meaning your slices are not the same.
Right. Yeah. Yeah. That's
Is does that I mean I can understand what he's saying, but the question is that material to what we are trying to do here? What do
I
you know?
think I think it's a we should definitely consider it because there was like 2 years ago there was this another competition where it wasn't MRI, it was brain CT, right? And it was not two classes, but it was like 7 or 8 classes. So when a person has a stroke, there is bleeding in the brain, so it can be like 7 or 8 types. Okay, and everybody, I remember like that time 2 years ago, everybody was trying to do 3D CNN models, and but the winning solution was like a sequential model. And in fact, maybe sometime we can review this solution, like and there was some of the stuff what you said, like the slices are different. And um, in that case, so when let's say somebody gets a stroke and goes to the hospital, right, the radiologist actually scans, looks at it in like very fast, right? They scroll through the images, and they were saying that this I can't. Can I zoom here? So look at the sequence, the solution he came up with, like, yeah, DICOM files, blah blah blah, 2D convolution, and then this pretty sophisticated sequence model, right? Like he has more work in the sequence model than in the CNN work. This is just like whatever ResNet or whatever basic. Um,
Mhm.
and the surprising, I remember being surprised because all of us were trying like 3D CNN, but among the top 10, maybe half, maybe there was a majority of sequence models were winning. So definitely something we can look at, like
So, so your point is that may be
me. Mhm.
a valid
Yeah,
comment
yeah,
um,
yeah,
worth considering. Okay,
yeah, yeah,
because
definitely worth.
that was a completely different direction that I thought that's interesting comment, because that would imply, um, I mean, uh, you can create the voxel, but still deal with it as a sequence of um, XY planes along the third dimension.
Right, right, yeah, yeah, and we can, yeah. Did he no?
Because you have
He,
resized, cropped, you have made it all kind of the same,
right,
but each slice you see it as a member in your sequence.
right, yeah, yeah, definitely worth considering, like, especially given how well it worked in some others. And this is also great learning, right? To learn this will be, yeah. I don't know how these guys do it, like how it just takes so much time to do these experiments. It's just like the number of pipelines and um, yeah. Anyway, just a thought, like, I don't know. Yeah, they even use some DICOM features and blah blah, and like do supposition.
Mm.
It's just yeah, okay. Uh, Yeah, that's all I had for today. Yeah. But yeah, I think it's a lot of things to learn and try out. And,
Yeah, and I was also kind of, when we looked at it last week or just 2 weeks back, the majority of the guys were in the point six, six,
yeah,
seven. And now if you look at the leaderboard, it's like at point, I think they're close to point eight, right? Can you pull up the
yeah, sure. Uh,
leaderboard thing?
yeah, some people crossed point. I think one team crossed uh, point. Yeah, 0.86 now. Wow.
Yeah, yeah. So I was like, wow, I mean, that's kind of quite impressive that people have quickly gone
Right. Yeah.
to, 0.86 is not, is at least far enough away, even if you can get by choice to random choice to point 0.6 something, it's
Right.
different to get to 0.86.
Right. Right. Yeah. Uh-huh. Yeah. Point. Right. Exactly. Yeah. This point. Yeah. This is the notebook where I
Yeah.
started with, but yeah, I didn't. I made some changes. I'm not at. I don't know how we got that, but anyway. Yeah. Anyway, we can check that.
In his case, he's using the DICOM images from what I can tell. And then in his case,
Yeah.
he's doing what I said, which is using each of the images, again, not, I don't know in the latest whether he does this, how would I call, make them all of the same
Uh.
orientation and all that.
Yeah. Mm-hmm.
Whether he does that or not, I'm not sure. But he trains 4 models, and I thought he then ensembles them. Is that not the case?
Yeah. Right. Right. He
Can
took.
you
I
just
think he.
quickly go down?
Yeah. He might have even. Yeah. I have it open. You can
And
see his
see,
note.
in fact, right here, Mehul, right here, what he's doing of the middle is I think he's just using some number of slices from the middle
Middle. Right. Yeah.
of
Mm-hmm.
every can type image.
Yeah, I should try this. Yeah, I should definitely try this. And yeah, this. Do you guys? Okay, just one programming question. Why is everybody writing code like
Yeah,
this?
that one. Yes, yes. Well, I don't know that you need to do all that. People have done it simpler, but the bottom
Okay.
line of what he's doing there, by the way, I mean, you can just do it simpler. But what happens is the slice. So I stared at it until I figured it out. Um,
Uh-huh.
that there's simpler equivalents of the code. But what is being done there is, see, when you have the images, right?
Yeah.
Unfortunately, the way the images are listed is like 1 0 and 1. The sequencing doesn't happen in the sequence of the slice because the ordering of 1 0 and of 100 or 101 and 15 or 11 is not the order you want. Do
Okay.
you follow what I'm trying to say? The
Yeah.
way if you select that thing, it will not show up in the sequence of numbers that you want because it kind of, I forget what the term is, where it sequences it. It puts 1 0 and then, 101 might show up ahead of like 15 or something.
Okay. Got it.
And that's
Yeah.
not what you want. You want the order to be like 001, 002, 003, then 4, then 5, then 10, 11, 12, rather than 10, 100, and all these things getting shuffled. So
Okay.
this thing sorts it in the integer order that you want
Okay. Okay.
of all the slices. That's what it does.
Okay. I see. Okay, and then I see. Then he just takes some slices in the middle, and okay, and just figures out how many he wants. Blah, blah, blah. Okay, and then create a stat. Yeah, this normally. Yeah, just yeah, why? Yeah, just normalize, and then yeah, like in the end, what does he do? Like you're saying, yeah, trains 4 models, uh, and yeah, yes, yeah, I was looking at. Yeah, I got close to this. My validation is like 0.608. I didn't, but it's bizarre. Like maybe I'm doing maybe I'm doing something wrong in the submission. Yeah, like he's 0.68 and I'm 0.5. Okay, and then finally he did. There's them split. What is this? Oh, this is okay. So do the prediction and then just
why does he divide it by length of the model file?
Model file. Maybe because he has 4 models. That's the number of models he trained. Wait, what? Why? What is this? Yeah, this is looping. Yeah, I think that's it. It's just the model files are, and this zip is another proper. People really seem to like zip, or he likes zip. I'm like, I don't know. So model files, and he does. God damn it! Where is this come? Predict. Yeah, that it's the 4 model files. So I think it's just divide by 4.
Okay. Yeah, that makes sense.
That's it. Okay, that's his. Okay. Maybe I have some simple bug somewhere. Why I'm getting 0.5?
Yeah, no. The other thing I'm suspicious of is the process. Somehow we have to ensure that the processing we are doing in the to create the voxels is working properly on the test data, right?
Right. Yeah.
If that has any problem anywhere, then we will not be getting the correct format for our
right. Okay.
For running the thing. And there is at least do you have any checks for that? And how can we check that? I was wondering about that.
Yeah, actually, you gave me an idea. I know how to, because for my test data, I'm doing the processing myself, right? But for those 87, so there is a the test data they gave us, and then there's a hidden test data, right? But at least for the test data they gave us, I have the NumPy file, so I can compare. I can compare the NumPy files I generated versus the NumPy files that already exist. Just do some subtraction and do a subtraction and do a sum, and it should be 0. So I will add that. I'll make a separate notebook to check that my processing is not messed up.
Yeah, because I was wondering how to check that.
Yeah, just by image subtraction and just check it, and even I can I did manage to, like, you can do some displays here, but some visual checks, or but the subtraction will be better. I should okay.
Oh,
okay, cool. I think
that's a lot of stuff to
Yeah.
review and try.
Yeah.
Yeah, I was just going through it. I just was getting to the part where I was building the training pipeline. So good, you kind of told us that. So great.
Okay.
Okay, thanks. If you can post a link to a couple of those and whatever others, I think I sent you my username kind of stuff. So,
yeah.
Okay, everybody. Anybody else want to share or comment? Okay. If not, thanks everybody for joining, and we'll do it again next week.
Yep.
Next week, is it the next week is not Labor Day weekend, so we're on for next week. Okay, Cool.
Okay. Bye.
Thanks, everybody.
Bye.
See you all.
Thank you.